Okay, now I realize I deleted all those files. All right, 1 through 3. Solve by graphing. You're just looking for the point where they intersect each other. We good 1 through 3. You can put it into point slope form if you want, or slope intercept form if you want, or you can just graph it as it is, especially using utility like Desmos. When will my graphs have let's start with this. When will my graphs have no solution? Let's just review some basics of graph solutions. Yeah?
And when the slopes are the same and they're parallel?
When the slopes are the same and the graphs are parallel. So if we look at the graph up on the TV where we had a slope of negative 2x and then a y-intercept of 8, if I have another negative 2x but then a y-intercept of 6, they're parallel and will never touch each other. When will they have infinitely many points of solution? Ava? When they're the same line exactly. And blue now exists on top of red. So if I shift my y-intercept, it moves. And then when will they have 1 point?
Oh.
Yeah?
When they intersect once.
Well, yeah, when their slopes are different, right? So when you have different slopes, you will find a point of intersection. All right, 4 through 9.
Wait, what form is this? Is this K?
This is G. The one that's in the packet is G. The one that's online, I think, is K, though. I might be wrong. I don't know.
Oh, my test is, I stapled it wrong.
Oh, yeah, I know.
So I was on the back.
Yeah.
But yeah.
Yeah, I had noticed that because I kept looking at it. I'm like, is there an O? 4 through 9, substitution. We've got a couple examples on the Schoology page, substitution. Anyone want to see anything?
I love substitution. What? I love substitution.
Okay, it depends on your brain. Some people like substitution, some people like elimination. Some people just don't like either, but then you might evaluate whether you should be in this class. Substitution, going once, going twice. Sold to the guy plugging in an expression for y. Elimination. Akash, what was your question, 13, 14? Yeah? 13, 14. So, these questions are fun, and I was working with somebody yesterday about the fact that we can multiply by whatever we want, and it doesn't have to be the same. No. Undo. 14. All right, so we are presented with 7x minus 8y equals 11, and then an 8x, 7y. So they're playing with 7s and 8s. I'm going to go ahead and copy down this over here to make my life easy. So 7x minus 8y equals 11. Now, what's the point of our elimination method? Like, what are we trying to do? What's our first step? So, Akash, I'm going to pick on you since you asked for this question. How do we eliminate? So that's a step towards how we eliminate. What needs to happen so we can eliminate terms? They both need to be equal. So right now, my x's are not equal, my y's are not equal, and they need to either be equal or opposite. So either equal or opposite quantities. Do you want to cancel the x or the y is the first decision to make, and then we got to decide what we want to multiply by. So do you want to cancel the x's or the y's? The y's, sure. So if we leave this equation here and then work the top equation over here, what do you want to multiply them by? So your bottom equation here, what do you want to multiply by? Negative 8. And the negative positive, that's totally up to you. And then over here, what are you going to multiply by? Just regular 7? Why'd you choose 7 and 8? They're going to get me to 56. So, negative 8 times 8x, negative 64x. positive 56y, and negative 56. 49x, negative 56y, 77. I'm going to go ahead and call this the A side since it was my top equation and this my B side. So how are you going to eliminate the Akash? You're going to do like A minus B, A plus B, B minus A, B plus A. What are you going to do? B plus A. So when Akash does B plus A, I have to take my X values, add them together, and I get, what's the difference between a negative 64 and a positive 49? Go from 49 to 50, and then go to 64. So we get the difference is 15, and the negative wins. It's bigger. My y's cancel each other out when I add them. And my constants, 56, 77, I get a 21, I believe. And then I just isolate my x, plug it back in, and find my y. So do you need me to keep going, or from here? And then because... actually should work either way. This is not lovely, but I would keep it at, well, this becomes 21 over 15, which ends up as 1 and 6/15, which is really awkward. This can reduce to negative 1 and 2/5. Ooh, that's not bad. So this is just negative 1.4. And then you can plug it in from there. Not terrible. So then 14, same relative process. Ooh. Especially if you have not done chapter 4 yet. This is, or even if you have done chapter 4 actually, especially even if you've already done chapter 4. This is one of those times where there is the what I can do, and then there's the what would be even better. So I could, double and triple. If I double this, I'll get 0.6. If I triple that, I'll get 0.6. I don't like all these decimals. All these decimal values are really annoying. So if I want to cancel out the y's here, I'm immediately thinking I can double this whole thing. Double that whole thing, triple that whole thing, and it'll be good. But this is one of those times, if I want to get rid of the decimals, if I want to use integer values, what could I do instead? Gosh. Ooh, we don't need to go all the way to 100, because I already know that the 2 and 3 will make this work well. What about just multiplying by 20 instead of 2? And then 30 instead of 3. Because then that times 20 gives me an A of 8x, I double and I shift over, plus 6y equals 34. And then my B equation, I can't take how thick this is writing, 21x minus 6y equals 24. Now I have nice integer values, opposite y values. If I combine my functions, I will be able to isolate my x. So even though you didn't need to multiply by quantities that large, it makes everything following that so much easier. Always look for the easiest way to do this. I don't know at what point we decided that math in American needed to be hard, or why we would need to make it tough for kids. Always look for the easiest option. If you can't find it, reach out to me. I will help you figure out how can I efficiently solve this problem. Back to the test. What else? Yeah, you. 16 and 17. Now 16 is really interesting. Excuse me, because if you only look at one part of it, you can easily get the wrong answer. I got really good at this process when I was making all my class notes, using paint and copy pasting. So, has anyone ever wondered, or actually no, here's a better situation. My brother, so I'm the youngest of 3 siblings. There's my brother, my sister, and me. At one point in our childhood, my brother was twice my age. And then we kept growing. Will he ever be twice my age again? So I'll go ahead and tell you. My brother right now, I'm 28, my brother's 34. My brother's 6 years older than me. When was my brother twice my age? When he was 12, right? Because if there's a 6-year gap. When I was 6, he was 12, he was twice my age. Will that ever happen again? No, because we're now both changing by 1 every time. Our rate of change cannot be different. We're both aging 1 year every year. The same holds true for Barb and Ann here. Barbara and Anna. Barb and Ann. Barbara, Ann.
Stop.
Beach Boys. So the people who write these math textbooks have a sense of humor. Barbara Ann is a song from the Beach Boys. Barbara, Anna. Barbara Ann. That song. Nobody. Come on.
I know that song, but I hate it so much.
Sorry.
I'm trying. I'm succeeding. I don't know about you. All right. So they give us these weird statements. 10 years from now. Well, 10 years from now, we know that Anna will have aged 10 years and Barbara will have aged 10 years. So 10 years from now, we'll have A plus 10 and B plus 10. Because right now, we're going to say Anna is A and Barbara is B. Those are their ages right now today. And actually, I should change my color coding here. Sorry, I did that a little bit too quickly. Always color code your problems to help your brain make sense of it. I don't care if you think it's necessary, your brain appreciates it. I'm not joking. Like, you may not realize it, but your brain appreciates it. So let's set up both of these situations. 10 years from now, Anna will be, but Anna is going to be A plus 10. Will be equal. It's a math equal word, right? Twice as old as Barbara. Okay, so twice as old as what? Is it twice as old as Barbara right now or twice as old as Barbara then?
Barbara now. Yeah. Oh,
Barbara, the 10 years, from 10 years from now, Anna then will be twice as old as Barbara then, right? We're talking about them in the future. But then they also tell me 5 years ago, Anna was, so 5 years ago, A minus 5, Anna was 3 times as old as Barbara. Well, that's interesting. But again, both of them are that 5 years ago. This is just a system of equations. If we isolate one, I broke it up. You can't drag it now. Let's work this. So I can go ahead and isolate. Any questions with how I got to here? just distributed, combined like terms. So then if over here, what should I do here now? Yeah. I could add 5 to both sides, but that's going to isolate the A again. And then I'll have, ooh, okay. I was thinking a different route, but this will work. So if I add 5 to both sides, I get 3b minus 10. But now I have A equals and A equals. So apparently Anne is twice Barbara's age and 10 years at the same time as being 3 times Barbara's age minus 10 years. If I have 2 different expressions for what A is, what should I do with them? I have 2 things. You can record, take pictures, do whatever you want to do. Yeah. I don't know what you were trying to do.
I was
but
taking a picture of it.
Yeah, and this is recording too, so it'll be on YouTube here later. But don't ever feel like weird about. I've gotten over the whole whatever. Take whatever pictures or video you need. I can set these equal to each other now. Let's use a nice purple pen. So 2b plus 10 is equal to 3b minus 10. Combine their like terms. If I take 2b away from both sides, I get just b here. If I add 10 to both sides, I get just 20. And now that I know how old Barb is, I can figure out how old Anne is. I'm not going to do the rest of that for you, because I'd be doing too much of it. But the tricky part is, who did I solve this with yesterday? Or no, they're not here. They were, that was Ella. So Ella was in here yesterday and we were working on this. We looked only at the first equation, only at the green one to begin with. This yellow highlighted situation. And we found an answer. We found that in 10 years, Anna was going to be 50 and Barbara was going to be 25. And that was wrong. But it worked for that situation. Anna will be twice as old as Barbara. Sure, 50 is twice as old as 25. We made it work. Both situations have to be taken into account at the same time. This is why systems of equations are used. What if I need this space shuttle to be going this certain speed at this certain time, but then also this planet is rotating at a certain speed at a certain time? I need both systems to work together to get that rover on Mars. I need both systems to work together to blow up that asteroid. You guys haven't heard about it. In like 2020 something, there's going to be an asteroid coming very close to Earth. Close enough that it might hit us. So they're looking at, how do we deal with this? How do we redirect it? Or how do we blow it up? Or how do we do whatever? If you haven't heard about it, Star Talk with Neil deGrasse Tyson is an amazing podcast to listen to.
Isn't it like the second sun that's coming behind the sun? Well, there is that too.
Yeah, that's different. But I'm talking about there's just like a meteor asteroid. I get confused on what you call it, where it is. Like it's a certain thing once. It's a meteorite once it's like on Earth. But there's, I think it's an asteroid right now, and its trajectory that it's currently on, like if you can imagine, this is going to be really bad. If you can imagine, here's Earth, and here's this asteroid millions of years away, and its trajectory is this way, right? So based on how far away it is, where it might be traveling could miss us or could hit us. It's one of those sort of things. So it's like, and then depending on how wide this actually gets, and they talk about this in Star Talk, so I will not take any credit. Let's say it was going to hit right here. And it's easier to push it this way. It's closer, right? It's a shorter distance. But what if more people are affected if it were to hit here than if it were to hit there? So which direction do we push it then? Do we want to do it the quickest route or the least possible destruction? So it's like this whole, and whose decision is this? So this is getting way off topic, But those are the sort of problems where systems of equations come into play when you're working with multiple moving objects. That's a system of equations. All right, so the weekly ratio of two persons, let's just go ahead and use Barb or Ann again. So let's say Barb and Ann, right, are 9 to 7. So I don't know what Barb does to make more than Ann, but I can also write a ratio in a vertical ratio setup or a fraction, right, comparison. And then I can make this a proportion because I know that that is 9 compared to 7. Maybe Barb makes $9 an hour and Ann makes $7 an hour. Maybe Barb's the manager. The difference in their weekly incomes is 200. How do I bring that into play? The difference in their weekly incomes is 200. Yeah?
Like 9b minus 7a equals 200.
Ooh, let's start simpler than that. So if you were just trying to represent the difference in their pay, so this might be hourly, this B and this A, but it might not be hourly. It might be like the weekly or the monthly, or we don't know what these values are. So what we know is what Barb gets at the end of the week. Let's just say that those are weekly then. Let's say this is Barb's weekly and this is Ann's weekly. Barb minus Ann, yeah, the difference between their incomes is 200. So if we now say this is Barb's weekly and this is Ann's weekly, then their weekly difference is 200. I've got a system of equations. Sorry that they're both the same color. My apologies. What can I do with a proportion to make it into a different type of equation? What if I don't want fractions involved in there? How do I kind of get rid of those fractions? Cross multiply, right? So 9a equals 7b. Now I could also then isolate the a and just say a equals 7b divided by 9. Do not use that as a decimal. It's going to be 0.7 forever, which will be gross. So then, since I know A, I can plug it in. And from there, I can do everything I need to do to find out what B is. And once I have B, I can plug that back in to figure out what A is. So remember, I'll give you one more step in the right direction. This is 1b minus 7/9 b. What's another way that I could write 1b? How many thirds does it take to make a whole? How many fifths does it take to make a whole? So how many ninths does it take to make a whole? Your life will be easier if you think about it like that. And then just to make sure, I'm giving you guys too much help, but we'll definitely figure it out in the future if you're relying completely on this. 2/9 of B equals 200. How do we destroy a fraction or turn it into 1? Yeah. Reciprocal multiplication. So that's where I'm going to stop. Utilize some reciprocal multiplication to solve for your B, and then use your B to solve for your A. Yeah.
Can you go over question 8?
I thought you were going to say 18. That's why I gave that word a little look. You've got a few options in 8. Yes, to answer your first question, yes, I will go over it. Now again, look at it to figure out how to make your life easy. Don't like just jump to what you think is easy. Play it out a couple steps. My mentor teacher, my first year teaching, Tim Dove, love him dearly. He's working with the, I think, National Board of Education now. He would always say, play what happens next. So if I do whatever, what then will happen after that? And think about it before you do it. So if I isolate x, right, this looks like it'd be the easiest option. Let's isolate x. Well, then I'm going to know what x is, and I'm going to be able to plug that in somewhere. So if I find the x is equal to, yay, then I get to divide it by 3. Who likes dividing by 3? And I'm going to end up with x is going to involve a fraction? Gross. Don't do that. It's a bad route. Now, you could do that. Just a bad route. I could isolate for y right here, but that's going to get even grosser because I'd have to divide everything by 2, maybe 2.5, and x over 6. Ugly. What else could I do? I know an option here for isolating something. Crystal. Where? Which function? Top or bottom? So in my top function, I can multiply by 2 to destroy that denominator. In my bottom function, I can multiply by 3 to destroy that denominator. And when I do that, I will get a same function, just rewritten, x plus 6y equals 15. So, Crystal, what would you do then? You're so good. I'm just going to go ahead and say, huh? So, to point it out, back when I was a kid, I would do things like this, and then I would realize, like, oh, I'm so stupid. I would have probably tried to isolate the y. I don't know why. Like, I just because that's one of the things that I would do. Realize the x is already by itself. All I got to do is bump this y value over. So if I just get 15 minus 6y, this, and here's the danger, came from the bottom equation, needs to go into the top equation. If you plug it into the bottom equation, you'll end up in an infinite loop because you're telling it what it already knows. You got this from the bottom equation. I need to use that information in the top equation to now say 15 minus 6y plugged in for this x plus y over 2 equals 4. Drop your parentheses to combine like terms. I'm going to go ahead and combine, well, no, I won't do too much at once. I'm going to go ahead and use just all fraction form. Because I got to take, or I got to add a half y. I'm at negative 12 halves. Add a half, I'm at negative 11 halves y. You could use decimals, it doesn't matter. It's just nice to deal with fractions because then getting rid of the fraction is easy. If I subtract my 15, from there, we just need to finish isolating the y. Once I have what my y equals, which I want to let you guys do on your own to make sure those skills are good. Once you have your y equals, well, more so, plug it in right there to find out what your x equals. For number 18, one thing I want to point out, and then unless people have questions, we'll pretty much be done. In 18, be careful. When you're looking at, or sorry, I don't want to be done with the front at least. When you set up D and N, and you use these variables, realize that's the number of dimes and number of nickels, not the value of them. So if you use like D and N here, that's the number, not the value. All right, other question. Anything else from the front? Let's just do that. Anything else from the front? Back. Anything through 21? Up to 24? And when we solve these by graphing, you're like finding a region. So it's not like some number answer, it's like there's a region that is the solution. So in case we haven't done these before, because I have some looks that are like maybe tentative. When you're doing the inequality graphings, if I start with my XY coordinate plane, let's say that I have some inequality that it is greater than some value with a negative slope. And I have some inequality that is less than or equal to, and the or equal to gets the solid line, as opposed to the greater than but not equal gets the dotted. And if this is less also, this part gets shaded, which means that my solution is everything in the overlap and the line, since the line was in the overlap. So that's what you're looking for. That's what it's going to end up looking like, something like that. And that region might be up here, might be down there, might be over there. They might be on top of each other. So sometimes, like let's say I ended up with another line that was also greater than or equal to, where their slopes are similar, not the same, but similar, then this would still just be the overlapping red-purple region, like if we were talking about the red and purple graphs. So sometimes they're on top of each other, and they're going similar directions. I see some eyeballs that don't like how I just did that. So if they had similar slopes, so this is all included. This section is not. This section is not. But everything blue and red is included. So they're both negative slopes. They're similar to each other. Makes it a bit more tricky to see, but it would be that overlapped region. Get rid of this little rogue blue mark. Any other questions about graphing these? Really try to get them in a slope-intercept is the easiest way to do it. If you need graph paper, I'd grab some now. I've got tons of graph paper, so feel free to take like a bunch and just stick it in your binder. So this is like your pies and cakes example that I gave you earlier, except it's egg cake and cream cake. Same thing though. You have $20 to spend instead of 100. Any other questions? Chapter 4. Once. Going twice. Sold the lady in the second row. Alright, so where we're at now then, because that's the end of class, which is awkward to begin with because class is kind of a relative thing. Next week, how things are going to look, and for every future face-to-face session. Tuesday, we'll kick off officially at 9, but if you want to get here at 8, that's perfectly fine. I'll be here, and we'll be open to work and do whatever. Bring coffee, donuts, whatever you want. Yeah, you guys can eat in here. You can drink in here. You can do whatever you want in here. Just treat the space as if it was your own. Respect it. So, future classes. We will be going over what is on the calendar primarily. So whatever's on the calendar for that week, so next week, that would be Chapter 5 and Chapter 6, those would be our primary things to go over. First thing we would do is take questions from any of the practice work. Then I would actually, yeah, because there won't be like questions from the assessments because the assessments will be being taken there. So we'll take questions from practice work just like we did with the assessment work today, just over the practice assignments. To take the assessment, the expectation is your notes are completed and filled in, and at least half of each homework assignment is completed. Last year I had a student try to do half of the assignments, like 1, 2, 3, instead of half of 1, half of 2, half of 3, half of 4. So choose evens or odds is my advice. If you want to do all of it, you're more than welcome to. But my expectation is that you solve half the problems. My expectation is also that you've checked your work. I do not want you coming in here saying, well, I don't know if I did this right. You have the ability, you have the tools to check, did you do it right? If you did it wrong, I want to help you. If you did it right, I want you to have that confidence that you did it right. You can check as you go. Don't do all of Chapter 5 and then check all of Chapter 5. Do 5.1 and then check 5.1. Make sure you're doing it right. Do 5.2, then check 5.2. Don't do the whole thing and then check afterwards. So we'll be going over homework problems. People can take face-to-face assessments. I can work one-on-one with people. I will encourage you, as you see from today, we have like 25 minutes left. We don't have a ton of one-on-one time when we have all the group time. So utilize my office hours, but please make arrangements with me. Do not just assume I'll be here. I'm normally not here in the afternoons. I'm not here in the afternoons unless someone has arranged it with me. And do not do like, hey, I'll be there in an hour. That's not cool. I need some heads up. I need like the day before. So if you're planning on coming to office hours tomorrow, you could go ahead, pull out your phone, shoot me a text, say, hey, I'm going to come to office hours tomorrow, whatever time. If you know that you need help on something, please let me know what you need help on so I can be prepared. Because I toggle through a bunch of different math classes. Sometimes I got to get my brain back up. There was another thought I had. Oh, and if there are like a bunch of people signed up, I might ask you to choose a different day. So like if I've already had 5 or 6 people contact me that they need my help, and you contact me, I might say, I've got a bunch of people coming, can we schedule a different time? That's why I want you to make arrangements. There have been times when I have so many people here during office hours, people are sitting around not able to get help because there's only one of you. I can't work with all of you at the same time if it's all different stuff. So please make arrangements with me. I text. It's the quickest, easiest way to get a hold of me. So I know it's weird getting used to the fact that you can text your teachers and everyone's got their own policy. You can text me. I totally encourage that. My first bit of homework is to go save all your numbers that you sent me. But that's the easiest way to get in touch with me. It's faster than email. Your parents might be like, no, respect it. No, it's fine. Text it. I'm not available, I won't reply. If you call me and I'm not available, I won't pick up. So text me, call me, use my cell phone. Okay? Any other questions? General. Stay on pace. Hold yourself accountable. But make it fun. Keep that balance. Make sure that you have that balance. Okay? Have a wonderful day. If you guys want to hang out till noon, you're obviously more than welcome to. But if you want to leave, you're obviously more than welcome to do that as well.
And they help.
All right. Let's help.
So